Welcome to the flock. Let's dive into this calorimetry lab where we're going to be determining the enthalpy and the amount of calories in a cheese puff and a Dorito. Let's light some Doritos and cheese puffs on fire. For this makeshift calorimetry setup, we're going to need to measure out 50 milliliters of water. Now, you could measure out a different amount of water. I just found that works really great in one of these cans. If you have an empty soda can, it's also ideal to use for this lab because you can throw it out afterwards when it's all scorched on the bottom. So first things first, let's measure out 50 milliliters of deionized water. Make sure you're always getting down at eye level to see the meniscus of your water right at the volume you want. In this case, the 50 milliliters. Now we're going to take this 50 milliliters and pour it into our makeshift calorimeter. Now we need the initial temperature of this water before we light anything on fire underneath it. Make sure you take your temperature reading in degrees Celsius, since that's the unit we need when we're doing our calculations. Our initial temperature is 24.5, roughly, degrees Celsius. Of course, make sure you write down this initial temperature. The next thing we need is the mass of our cheese puff before we light it on fire. Make sure you're putting your snack item in a weigh boat, since there's lots of grease and oil that we don't want to get on our scale. Looks like we're starting with an initial mass for the cheese puff of 1.05 grams. Now this next part is going to involve fire, so make sure you have the proper fire safety tools available. We're going to take a lighter, light this cheese puff on fire, and hold it underneath our can to heat up the water. Now the whole point of that is that the heat energy released from the cheese puff as it's burning is going to get transferred to the water. Now the difference in temperature from the initial temperature of the water to the final temperature of the water is going to tell us how much energy was in the chemical bonds of this cheese puff. And we can use that to determine the calories. Also, if you're conducting this at home, I highly recommend that you disable your fire alarms, at least for the duration of the experiment, because, yeah, fire. Here we go. And this is the exact reason why using a disposable can is really great for this lab. All right, the cheese puff has come to a final resting state. Let's make sure we can get the temperature of our water. When you're measuring the temperature, try not to have the thermometer hit the bottom of the can. You don't want it to read the heat on the bottom of the can, just the temperature of the water itself. Looks like it's gotten all the way up to 42 degrees Celsius. Now it's dropping again because it's cooling down, but at its hottest temperature it was 42 degrees Celsius. It's also important to note that the entire cheese puff didn't burn here. I still have some cheese puff left over that did not ignite and did not contribute to the heating up of the water in the can. So that definitely poses some error. Let's take the final mass of the piece of the cheese puff that didn't burn so we could subtract that out from the initial mass that actually contributed to the reaction. About 0.39 grams worth, give or take, because a piece of it did burn, actually. Still pretty hot. Whew, look at that black soot. Now we're going to do the same thing except with a Dorito chip. I've already poured in my 50 milliliters into my new soda can, and this time we see the initial temperature is closer to 25, so maybe 24.9 degrees Celsius. Let's find the initial mass of our Dorito chip. 1.05 grams it is. Coincidentally, that is the exact same mass as the cheese puff was. That was entirely not intentional, actually, oddly enough. And now it's time to burn with me. Got a nice little flame going for the Dorito chip. Whoo, buddy. All right, quickly take that final temperature before the water cools off. Just as I suspected, the temperature is warmer than the cheese puff, simply because it burns so much longer. Looks like our final temperature is 51 degrees Celsius. Nice. The Dorito almost burned to completion, so I don't think it's necessary to take the final value of this guy, since we've only got that little tiny sliver that didn't burn, where I was holding onto the chip. Let's take these values back to the classroom and do the calculations for how much enthalpy and for how many calories are contained in the cheese puff and the
Do you have a friend that just got a new keyboard and has absolutely no idea how to play it? Then get them
Dorito. Now that we've seen the experiment carried out and we gathered the following data, let's use these experimental values to calculate the energy in joules. Using our energy of heating equation up here, we're going to first solve for Q in joules. Remember that this is all in reference to water. So the mass that we're concerned about here is not the mass of the snack that we lit on fire, it's the mass of the water that we used. But you might be asking yourself then, Dakanta, you didn't weigh the water before you did the lab experiment, so what are we supposed to do? Here's the thing. Water's density is 1 gram per 1 milliliter. Since we used 50 milliliters of water, we can assume that that 50 milliliters of water was equivalent to weighing 50 grams. We're also going to need to use the specific heat for water, and that specific heat value was 4.184. Don't forget the units here. It's joules divided by grams times degrees Celsius. So again, our gram value is going to be the 50 grams of water that we used in the experiment, which is equivalent to the 50 milliliters. And the change in temperature, or delta T for our water, is final minus initial. So for the Dorito chip, that was 51 degrees Celsius minus 24.9 degrees Celsius. When we subtract those two values, we end up with 26.1 degrees Celsius. Now all we have to do is multiply this value by 50 by 4.184. And you'll notice we'll be left with units of joules because our grams will cancel and so will our degrees Celsius. When we do so, we get a Q value equal to 5,460.12 joules. That's quite a bit of energy for just a fraction of a Dorito chip. Now, of course, the big question of the day is, how many calories is that? We're going to use our conversion factor from our previous calorie video, linked in the description below if you're curious as to where that value comes from, to convert our joules to calories. Let's start with our given, which was our 5,460.12 joules in our little piece of Dorito chip. And now we're going to plug in our conversion factor here, 4.184 joules per 1 calorie, and that's a calorie with a big C. We see that our units of joules cancel and we're left with calories, so all we have to do is take this number and divide it by this number. And we end up with an answer of 1.305 calories. So in that one little fraction of Dorito chip that only weighed 1.05 grams, there was 1.305 calories. So of course then we can also use that to solve for the calories per gram of that Dorito chip. It was, after all, just a fraction of a Dorito chip, not even a whole one. So let's figure out what the calories per gram would be. In this case, we know we massed out 1.05 grams of Dorito chip. So that would give us units of calories per gram if we divide these two values. And our final answer here is 1.243 calories, big C, per gram of Dorito chip. Now that you've seen me walk through all the calculations for the Dorito chip, go ahead and pause the video here and see if you can solve all the calculations for the cheese puff. Remember that the initial temperature was 24.5 degrees Celsius and the final temperature was 42 degrees Celsius in terms of the cheese puff. Ready? Go! Let's see if you got your cheesy cheese puff answer correct. now initially we know the cheese puff weighed 1.05 grams. However, not all 1.05 grams actually burned heating up that water. We only had a portion of it burn. So we found that the puff that had not burned left over weighed 0.39 grams. So in order to figure out how much actually burned, we need to subtract these two values first. When we do so, we get 0.66 grams of the puff that actually burned in this chemical reaction. So now, of course, to figure out the calories per gram, we're going to need to take the calories we calculated before and divide that by the grams of cheese puff that actually burned. 0.875 calories divided by our 0.66 grams of the puff that burned. And when we divide those two values, we get a grand total of 1.326 calories per gram of cheese puff. By doing some calculations, I found that the molar mass of a Dorito is 7.0004 times 10 to the 23rd grams per mole. How did I get that value? Well, I just took 7 pieces of Doritos and I weighed them in a weigh boot on a scale, and I took the average of what those 7 little pieces of Doritos was. The 7 little pieces of Doritos weighed 8.14 grams, and there was 7 of them, so the average then would be 1.163 grams per Dorito chip piece. Then if I take that value and I multiply it by a mole, and a mole is literally 6.02 times 10 to the 23rd, I can figure out how much 1 mole of Dorito chip pieces would weigh, and that happens to be that value there. Now I can use that information to solve for the delta H, or the enthalpy, of the Dorito chip in kilojoules per mole. I know that I used 1.05 grams of Dorito chip in the experiment, and I also know that my molar mass of Doritos is 7.0004 times 10 to the 23rd grams per 1 mole of Doritos. So in other words, if there was a mole of Doritos, we would basically be drowning in them all over the entire earth. My grams cancel, and I'm left with moles of Doritos. So when I divide 1.05 by 7.0004 times 10 to the 23rd, I end up with a very tiny number of moles of Doritos of 1.4999 times 10 to the negative 24 moles. So a very, very, very small amount of moles of Doritos. So I have the denominator now, I have the moles of Doritos, I just need the numerator, the kilojoules of energy produced from 1.05 grams of Dorito. Well, we already did the calculation and found the joules. All we have to do is convert that joules to kilojoules. From the lab experiment calculations we've already done, we know that the joules of energy produced from the Dorito was 5,460.12 joules. In order to convert this to kilojoules, we know that kilo is a unit of 10 to the 3rd power. So we're just going to put kilo next to the joules, because those will multiply together, and that'll just make it so that this number divides by 10 to the 3rd power, which is again equivalent to kilo, or 1,000. Keep in mind that this is the long way of doing it. There's also the shortcut where you just move this decimal over 3 places. But you should end up with a value of 5.46012 kilojoules. Now we have kilojoules, and we have mole, and we're trying to find kilojoules per mole. All we have to do is divide these two numbers. So then the delta H of our reaction, or the enthalpy of the reaction of this 1 piece of Dorito chip, ends up being 3.64 times 10 to the 24th power kilojoules per mole. That's quite a lot of energy per mole of Dorito chips. But then again, 1 mole of Dorito chips is quite an awful lot. Now there's one last step here that we need to consider. When we're talking about delta H, we know that there are negative or positive delta H values. If the delta H is negative, we know that that's an exothermic reaction. If the delta H is positive, we know that that is an endothermic reaction. In this reaction, we definitely produced heat, so we're looking at an exothermic reaction. So really, this should be a negative value, indicating that the delta H is exothermic for this reaction. Now it's time for you to try the cheese puff calculation for enthalpy, or delta H, given the fact that 7 cheese puffs weighed 7 grams. Make sure you determine what the molar mass is first, and then go from there. Pause the video now to give it a try before I show you how to do it. How cheesy is your enthalpy of cheese puff? Let's find out. When you use the mass value to cancel this gram value here from the molar mass, make sure you use the mass of the cheese puff that actually burned. That's our 0.66 grams, not the 1.05 grams. And so you see, our final answer is 3.34 times 10 to the 24 kilojoules per mole. But wait, there's more. Don't forget the fact that this reaction produced heat. It was exothermic. So our delta H value needs to be negative. Make sure you plug in that negative there just to show that it was exothermic, even though the calculations didn't yield a negative number. In this lesson, we learned how to perform a very basic and very rigged calorimetry lab, which is not as good as a bomb calorimeter, but it'll serve the purpose just fine. Using the data we gathered from the experiment, we were able to calculate for the energy in joules of a Dorito and a cheese puff. Then using that value, we were able to find the calories of a Dorito and a cheese puff. And then of course, we were able to take the mass of the snack we started with and figure out the calories per gram of the Dorito and the cheese puff. Last but not least, if we figured out the average of the mass of Doritos and cheese puffs, and then figured out how much the molar mass would be using Avogadro's number, 6.02 times 10 to the 23rd, we were able to take that and the joules converted to kilojoules of energy divided by moles to find the enthalpy of a Dorito and a cheese puff. And also touched base on the fact that we need to indicate our delta H as a negative value since this reaction was definitely exothermic, producing quite a bit of heat. Please give this video a quacks up, and when you're out of luck in chemistry, subscribe to the duck. Quack you later.
No ducks, no glory.